Good morning, everyone. Hello.
Hello.
Today I'm going to represent you a preliminary study on one of my students. Let me introduce myself. I'm Rana. I am working at Cyprus International University. I'm the head of Environmental Engineering Department. This study has been in its preliminary stages. My student Muhammad had finished the first part, so I'm going to represent that to you. The table of content is the objectives, literature review, some points about sampling, materials methodology, results, discussion, and then conclusion. What did Muhammad aim doing this research? Oops, sorry. Actually, we are living in a small island which is having scarcity of water. So every drop of water matters. So he intended to have a study about disinfecting the wastewater for its reuse. This reuse study was for irrigation in non-crop fields, let's say. So the main objective of this research is to find the minimum disinfectant doses for two different chemicals, and the contact times, the minimum contact times for ozone and the UV light, which are also disinfectants, to require the level of the pathogenic microorganisms in the wastewater to reach the levels for non-crop irrigation standards. So what did people do and what are the literature about this topic? The water quality standards of wastewater irrigation are established depending on the type of the subjected crop. The World Health Organization's differentiation of unrestricted irrigation and restricted irrigation is based on whether the subjected crop is consumed raw or not. If you are consuming it rawly, it has different standards. If you cook it, it has another standard. Also, the EPA, Environmental Protection Agency, classifies the crops into either food crops or non-food or processed food crops. So in Cyprus, we also have this differentiation. Using untreated wastewater, which may have pathogenic microorganisms in it, for agriculture can cause parasitosis or waterborne epidemics. So there are many backbones of this. So it's not recommended. It's inappropriate to use disinfected wastewater for irrigation. So how did we do sampling? He was going to do samples, so to find the microorganisms in these water samples. He collected them directly into plastic sample containers. Then he kept them unopened until the analysis. When the cap is removed, he was very careful not to do any contamination with the surrounding. During the sample collection, the sample container was plunged into with the neck part of the sampling bottle below the surface. Then after collection, he just kept it to avoid the contamination. Then what did Muhammad do in the laboratory? He had used different methods. Two of them are chemical materials, calcium hypochlorite and sodium hypochlorite, which are known disinfectants. Then he had used some mechanical or, let's say, physical means, like ozone or UV generators. He also used pH meters, membrane filters, incubator, autoclaves, which are some standard tools to use for microbial analysis. The wastewater disinfected in different disinfectants doses and contact times, and the fecal coliform is used as indicator microorganism to find the level of microbial water pollution. This technique maybe you're familiar, the filtration technique he had used in laboratory. So what was found? To know the fecal coliforms, you know fecal coliforms are resulting from the human or animal extractions. Is it the correct word? So the CFU, the coliform forming units per 100 milliliters, was measured. So the sum of the colonies in the total samples was divided by the total volume of the sample, which is quite easy to calculate. Then all those results he compared with the international standards for non-food crop irrigation. These standards differ from country to country. If you look at the United States, it has to be less than 200, which is a quite strict standard. For Turkey, we have the same limit. If you look at Australia and Germany, they have very low standards, like it has to be equal to or below 10 colony forming units. But if you go to some different parts of USA, Austria, Sicily, they have higher limits, like less than 1,000. For Cyprus and Greece, let's say, they have the highest standards, around 3,000 or 10,000. So, as you see, the world doesn't have a consensus about this. So all this study was performed 3 times, like the previous presenter has also explained, to have accuracy and precision. If the results were out of these limits, they were eliminated. Here are some preliminary graphs that you can see. For the sodium hypochlorite, he has standard with a great number, like around 500,000. Then, increasing the concentration of the disinfectant, he was able to reach lower limits, like around 40, 50. So, it was successful. But he had to use high amount of disinfectant. So, maybe you're familiar with the chlorination chemistry, but when you apply any form of chlorine to water, these are the 2 species that you have in the water, HOCl and OCl. Hypochlorous acid, which is HOCl, is more effective than the other ion. So that should be our aim, to have this more in our water. For this purpose, you have to look at the dissociation constant of the acid, which is quite low. So you have to be more on the acidic side. But as we have measured our wastewater, which we have taken from our campus, it was on the basic side, which is like around 8.3, and the temperature was around 22, 23 degrees Celsius. So it means that we were not able to have most of our disinfectant as HOCl. Maybe that would help to reduce the disinfectant concentration. So this is what I already have explained. If you look at calcium hypochlorite, it has the similar trend. The starting point is of course the same. Then going up to 9 milligram per liter of calcium hypochlorite, he was able to reach very low fecal coliform concentration, which is below 10. Also for sodium hypochlorite, it has a similar trend. So to kill all the fecal coliforms, 10 and 13 milligram of calcium hypochlorite and sodium hypochlorite were required. And the interesting and important point is 2 milligram liter and 1 milligram liter of chlorine residue left in the wastewater, respectively, to these applied disinfectant concentrations. I will discuss if it is good or not later. These are the residual concentrations of available free chlorine. Let's look at ozonation, which is a new technique for disinfection, not new, but newer than the other chemicals. Now we have to look at the application time, because it doesn't have a concentration. So we were able to reach very low fecal coliform concentrations at around 20 to 25 minutes. So it means you have to apply ozone for this time. And for the UV, now the application of time is around 40 to reach very low limits. So what do we conclude from these preliminary studies? The number of fecal coliform in wastewater effluent was significantly reduced to below the standard, only with the exception of the standards of Australia and Germany, because it is less than 10. So we can conclude this wastewater can be used for wastewater irrigation after disinfection. By each of the disinfectant, the number of fecal coliform gradually reduced by increasing the dose of the disinfectant and the contact time. In the calcium hypochlorite dose, 10 milligram, and the sodium hypochlorite dose of 13 milligram, the number of fecal coliform bacteria reached the standards. And for the ozone and UV light, 28 and 45 minutes respectively were required for reaching these standards. But there are some pros and cons of these methods. What are they? If you are going to use chemical disinfectants, okay, it's effective and cheap, but it leaves residues. What is the negative point of this? These disinfectants, chlorine left in the wastewater may damage your green ground wherever you are irrigating. For the ozone and UV, it's again effective. It leaves no residues, which is good, but they are expensive because you are using electricity. So you have to find which method is used for your own purposes, and it depends on your resources. Here are some references that Mohammed has used, so he's going to continue his studies, I believe. Thank you for your attention.
Thank you, Rana.